Hey everybody, Johnny here. In this video, we're going to look at a geometry node setup that can rig a tank track like this. The animation you're seeing right now is only keyframed on the empty that these two tracks are parented to. All of the track motion is generated with geometry nodes based on the movement of the tracks. So let's dig into it. One of the first things we'll need is what one segment of our track looks like, and then what path the track is going to follow. So I'm going to model something up real quick. This will be available in the source files on Patreon. If you want to get those, you can subscribe over there. I'll put the link down in the description. So while this is pretty simple, this will serve as our basic track piece. Now let's create a curve that will have our track follow. So I'll add a curve circle and we'll go with that just for the time being. Next, if you watched my tutorial on creating an automatic wheel rig, and I'll link to that down in the description, we're going to add a mesh object that we can use as our container for our geometry nodes. So I'll just add a mesh cube. It really doesn't matter what you add here, as long as it's a mesh of some kind. And then in the geometry node editor, I'll add a new node tree. Now we're going to want to bring in the curve for our path, and we'll do that with an object info node. So over here, we'll grab our picker and pick our Bezier curve, and I'm just going to send that to the output. Now, one of the things that I've been looking at recently is a way to be able to grab onto an object that has a node tree on it when I'm outside of my node editor, because sometimes you've disconnected all of the geometry and you're left with nothing to actually click on. So what I'm going to do is I'm going to add a curve primitive star and then a join geometry, and then I'll use a transform geometry and I'll rotate that on its y-axis, and I'm just going to make it a little smaller. Now at any time, no matter what I have for geometry coming out of my node tree, I have this star that I can use as a clicking point, because since it's just a curve, it's not going to render anything. So I can just put those out of the way for now. The next thing we'll need is to bring in our track pieces. So I'll duplicate this object info node and select our track piece. You'll want to make sure you're naming your inputs as you're going, just so that you don't have to go back and do a lot of work later. So this first object is going to be our path, and the second one is going to be our track segment. Now to put our track pieces on our curve, we're going to do an instance on points. So on our path, we'll add an instance on points node, and we'll connect the geometry from our segment. Now currently, this Bezier curve only has 4 points. And so it's put one track segment on each point. What we'll want to do is change this from a curve to a points array. So we'll do that with a curved points node. Now this node will give us the access we need to add as many or as few segments as we like. So I can increase this until I get to about where I want to be. We'll tweak that in a minute to make it more exact. One thing to notice is where the pivot point of my track segment is. It's off center here, and it's not on either end of the track. So I want to edit my track segment and line up the pivot point with either this back hinge or the front hinge here. So now when this rotates, it's going to rotate on this back hinge. And so you can see now that that back hinge is aligned with our curve. So that's a good step. So next we want to rotate these so that they are pointing towards the next hinge position. And we can do that using the rotation in our instanced points. But how do we figure out where they need to rotate to? So think about it this way. If we have this point and we want this track segment to point this way, we're going to want to draw a line from here to here and then align the rotation of our track segment to that line. So how can we accomplish that? The first thing we'll want to do is find out where each track segment is actually centered. So to get the position of each one of these points, we can use the sample index node. We'll give it the points that we have, and then from that we want to get the position, which is a vector, and we'll want to get the index. So we're going to add the position node. So we're sampling the position, and then we'll add the index node. So that means at every index, we're going to ask what the position is. And this will give us the beginning point of each one of our segments. Now, if we want the line between 2 points, or the vector between 2 points, we subtract the first one from the second one, and that will give us the vector that goes between those 2 points. Right now, this is asking for the position of each index as we evaluate that index. If we just change this index number and add to it or subtract to it, we can get the value of some other index. So if we're currently evaluating index 1 and we add 1 to this node, then we're going to be able to evaluate index 2. So I'm going to grab these 3 nodes and drop them down here. And then I'll add an integer math node. And I'll simply add 1. So this is going to get the position of the next point after whatever index we're currently on. So by subtracting these points, I can get the vector between them. So I'm going to take the second point here and do a vector math subtract of the first point. And so depending on which one we're talking about, it will align to the next point. But there is one little issue here. This index is going to go from 0 to however many of these segments we have, minus 1. So if we've got 15 segments, it's going to go from 0 to 14. But if we're on number 14 and we add 1, we're actually on 15, which doesn't exist. So we're going to want to have it wrap back around to 0 if we get to 15. So how do we do that? We use a math node, and we set this to the wrap function. The minimum value of this wrap is going to be 0. So that's where it's going to start. And then we can simply set the maximum to however many points we actually have in our nodes. So we can take this and bring it down here and do a domain size. We'll choose point cloud and plug that into the max. So now if I'm on the last point and I add 1, it's going to wrap around back to the first point. So now how do we use this vector that we've created to align our segments? Well, we want to affect the rotation of each segment, and we currently have a vector. So what we can do is we can align the rotation to a vector. Well, to get there, we can just simply say to align the rotation to a vector, which is this node here. We plug in our vector and we plug in our rotation. You can see that these have started to move in the right direction, but they're not quite there yet. we're going to need to pick which axis aligns to the vector and which axis is our pivot point. If we look at our track segment here, and I come over to my viewport display and show my axes, you can see that we want to align the y-axis with the vector, and we rotate on the x-axis. So I'll align the y, and then I'll pivot on the x. Now you can see that things aren't quite right yet. And if we look down through our node tree, we'll see that I've made a small error here. I've forgotten to connect my second index to the geometry. So I'm going to do that now. And when I do, I get what I'm looking for. One thing we might notice is that the part of the track that I expected to be on the outside is actually on the inside. So I want these to point in the other direction. So to do that, instead of looking at whatever the next point is and going from my current point to the next point, I'm going to go backwards and point to the previous point. And so to do that, instead of adding 1, I'll add -1. And so now you can see that the rough part of my tread is on the outside. Now let's take a peek at lining these up a little better. You can see that my tracks aren't aligning correctly here. And this is where I would need to do a little bit of hand manipulation to get the path and the size and the count just right. So here at 14, I'm very close. And if I come and edit my path just a little bit, I can get those to line up pretty well. And the other thing I'm going to notice here is that because of the size of my track pieces, this corner here isn't going to work. It's too tight a turn for this track. So I can either adjust my path so that it can compensate for the size of my tracks, or I could shrink my tracks down a little bit, which I think is what I'm going to do. So I'll simply shrink my track down and then apply my scale. Now that I have that, I can simply re-increase my track count. And I'm getting something that looks pretty decent. Before I go any further, I'm going to go ahead and clean up this node tree before I start adding any more detail to it. The next thing we'll want to be able to do is move the track segments around the path. So there's one method that I've found to do this, and there might be others, but this is the one I'm going to show you is the one that I've come up with that seems to work for me. I'm going to pull my group input and object info away from my conversion to the points, and we'll work in this space here. Now, the thought process that I've come up with is that if you have all of these points around this curve, and you simply look at where each point is, and then you find out if I add a certain distance to that point, where would it be? So if I was right here on my path, and I moved 1 unit forward, say to here, I could say, what is the position that's 1 unit further along the path than I currently am? And then I could set my current position to that new position. And just like my points, how I wrapped around when I got to the end, I could do the same thing for the length of my curve. So if I'm at the end of the curve and I add a little bit more, I go back around to the beginning. So let's see how we might accomplish that. We're going to want to be setting the position of our points. So I'm going to add a set position node. And we need to find out where we currently are on the curve. So to do that, we would use a sample curve node. We'll connect up our curve. And we're going to be doing this by length. I'm going to want the position of the point we are currently at. So I can use a spline parameter node. And just like the index node or some of the other nodes, this is going to give me the current length along each curve that my point that I'm evaluating is at. So if I'm evaluating point 1 and point 1 is 3 units along the curve, this is going to give me a length of 3. And so I'm going to plug that here into the length, which means I want to evaluate the value, the position, the tangent, and the normal at whatever my current point's length is along the curve. So if I plug this into the position, nothing is going to change because I'm just looking at the current point. I'm getting its current length. I'm evaluating the curve at that current length and pulling out the position, which is where it currently is. And then I'm just setting it to where it currently is. So nothing changes. However, if I were to add something to this and say, give me where I'm currently at lengthwise plus a little bit, and then get that position, I would be getting something a little further down the curve. So let's add a math node here, and we can add a value. Now, this is going to freak out. The reason is that, remember, this curve that we're starting with only has 4 control points on it. So it doesn't have a whole lot of data to work with. But if I were to take this original curve and add a resample curve node to it, and I'm going to set this to evaluated, this just means that that smooth curve that you saw that was being controlled by those 4 control points is now going to have enough points to kind of generate that curve, that smooth curve. We'll take that and we'll use that. Now, if I add here, it does a little better, but you see that it collapses on itself. And the reason for that is because as I add to these points, it's going beyond the length of the curve, and so it starts to fail. So this is where we need to add that second wrap node. If I duplicate this math node and bring it over, and then I set this to wrap, again, my minimum length is 0, and my maximum length I can get with my curve length node. So if I grab this and add a curve length node, I can use that as my maximum. So now if I change this added value, I get a nice smooth movement around my curve. The last step that we're going to want to do here is simply to hook this up to a simulation so that as we move this tank track in an animation, it's going to pick up the movement of the tank track along its primary axis, and it's going to use that to set this value. So we did this in the wheel rigging video. We'll do it again quickly. I'm not going to go into the specifics of the converting from world space to local space. If you're interested in that and seeing why that works, go back and check out that wheel video. So here I'll add in a simulation zone. And I want to get the current transform of my object. So I'll use the self object node, an object info node, and hook that up. And now this transform will be the current transform of the object that holds my node tree. I will feed my simulation with that transform. I'll also take that transform and feed the output of my simulation with that. So this means at the first frame, I'm priming my simulation with the current transform, and I'm setting the output as my current transform. But then on the second frame, this inside socket is going to be the previous frame because I seeded that here, and this one will be the current frame. So after the first frame, these two sockets will be the difference in transform between the first frame and the second frame, the third frame and the fourth frame, and so on. Now I want to convert this world transform into a local transform. I'll take the inverse of my previous transform, and then I'll multiply that by my new transform. Next, I'll separate that transform, and I'll separate the translation, and these will give me the local translation of my geometry node object. So I want to create a variable now that I can store my sum of my movement for the direction that my track is moving. So if I look at my object here and I turn on its axes, we can see that we want to find its movement along the y-axis here. So it's this axis that we're going to want to get. But what do we want to feed it with? Well, we're going to add a value, and we'll plug that into another one of my simulation sockets. We'll continue that value to the output of the simulation, but then we'll also add a math node, and we'll add in that y component. So now this value is going to be keeping a running total of the y movement of our track. So now on each frame of our animation, we can grab that value and use it to drive that add value that we had down here. So now to connect these all up, first I need to take my geometry that is currently completely separate from my simulation and connect it in. So I want my curve to points to be after my simulation has happened. So I'm going to plug this in here. And then the set position should happen on every instance of the simulation. So this is going to be on the inside. Now that my set position is inside my nodes, I can now take this cumulative distance that's been traveled and use that to drive this value that we created down here. So now if I go ahead and start my animation by pressing my spacebar, and I just grab my track here and move it, you'll see that it does move. Now it does feel kind of jittery when you do it this way, but if I go to my first frame and insert a keyframe, and then move forward a bunch of frames, move it over here and insert a second keyframe, and then play my animation, you'll see I get a pretty smooth result. Like the video that I had at the beginning here, if I go ahead and delete these keyframes, make a duplicate of my track, select both and use Shift S to have my cursor to selected, add in an empty, and then parent both of these to that empty. I can do a similar thing with my keyframes. And now I have both tracks working. And even if I come here and I rotate my tracks, you'll see that they do spin backwards and forwards like they're supposed to. So there you have it. We've rigged up a couple of tank tracks to spin around their paths as we move the geometry node holding object. I hope you learned a little something in this video, and I hope it expands some ideas that you might have for your future projects. As always, thanks for watching. I hope this video inspires you to make something awesome. And until next time, I'll catch you later.